The xCITE Lab is a unique, state-of-the-art facility for machine learning.
Over 70 terabytes of SSD storage.
Probably the most GPU resources on campus.
The capability to create VR products. We have this display wall that we use, and we can use it to show demonstrations.
All the machines in here are custom built.
Everything that we have in here is the top of the line.
And we have the expertise, and we have machines to actually accomplish the task that they're looking to accomplish. The purpose of the xCITE Lab is to help research faculty as well as businesses. They can come to us and we can develop the tools to better visualize their data.
One of the machine learning projects I'm working on right now is to take the Mesonet images that we have to be able to recognize if it's clear out, if it's overcast out, if it's cloudy or partly cloudy. Let's say you're doing 1 image per second. You could run that on your laptop. If you have like thousands or millions of images, you're going to be waiting till you get old to get it done. Our machine that we have, it could do close to 50,000 images per second using all the resources that we have.
This lab is filled with software engineers and people who can actually develop and know the code and know the different tools out there computationally, but also is this a building filled with scientists. And so if there are folks in other departments and other colleges who are interested in introducing machine learning into their research and they need the resources to do so without having to go to some heavier hitters like Amazon and Google, we would definitely be the place for them, especially since we're local. And we have new technologies to visualize the data and better solutions for communicating our data to the outside world.
The University at Albany is very proud and lucky to have one of the largest concentrations of atmospheric scientists in the country and the largest in New York State. We have the Atmospheric Science Research Center. We also have the Department of Atmospheric and Environmental Sciences. We also own and run, having built, the New York State Mesonet. It's a world-changing network of weather observations across the state. There is nothing else like it in the country or anywhere in the world. We have the xCITE Lab, which is state-of-the-art computing resources as well as visualization. And we have just great faculty, great staff, and great students. It's interesting working in New York State because we have a lot of severe weather, be it in the winter or the summer. And what's relevant to NYSTAR is the fact that most businesses are sensitive to weather as well as climate. I'll give you an example. Utility companies have to make decisions on whether to deploy crews ahead of extreme weather or after extreme weather. Utility companies are the easiest companies to work with because they know very well that they are sensitive to weather. That could be just due to severe weather in the winter, icing on the lines, bringing trees down. So all the sectors are impacted, be it utilities, renewables, transport, commerce, agriculture. They're all affected by weather. So our job is to do the research, to find the pain of these companies and what they're doing about the weather now and how they can deal with it in the future. By dealing with it and mitigating it, you can save money, save jobs, make money. I enjoy educating companies about the weather sensitivity they have, and I enjoy exploiting the tools that we have here. These are resources that can be used by business across the state. And we also have a culture here where faculty, staff and students want to do applied research for the benefit of these companies and the economic development of the state. And I think that's a huge advantage that the businesses have, not only in the capital region, but across the state.
I'm Jerry Brodsky, the program manager for the New York State Mesonet at University at Albany. We're on the Empire State Plaza, and we're installing a mobile tower for a weather station, and we're doing that primarily for educational purposes to demonstrate what a weather station in an urban setting looks like. We'll measure everything from air temperature, relative humidity, air pressure, wind speed, and wind direction. And all of that data will be collected in real time every 5 minutes, and we'll actually have it on display on monitors down beneath us in the concourse area beneath the plaza. An urban environment's a challenge because of the blockage from the buildings and the concrete, and our typical standard site is 33 feet tall. This is 106 feet tall, and which is actually good for an urban monitoring because you're getting the winds up above some of the building heights. This is where the people live, so that can provide a lot of valuable information for emergency managers. Well, today we had really an open house for the media. We celebrated actually the 1-year anniversary of our last site installation. We just finished tours showing off the operations center. It's important for people to understand exactly what they have available, what they've paid for through their tax dollars, and what a tremendous resource is now available to the entire general public.
With weather, data is the key. We always want more and more data. With this network of stations and the proximity that they are, and it's centered right here, it really does allow us to look in depth as to what the weather is going on at different locations. It's just an invaluable tool for us as meteorologists to have this window on all these different locations.
The University of Albany has the expertise across a lot of different spectrums that make something like this possible, because we have instrumentation experts, we have climate experts, we have weather forecast experts, and you need all of that together in one place in order to make something like this work. We're just now getting to the point of really developing these partnerships where you're going to see the impact of the data start to really improve the decision making. I'm Jerry Brodsky, the Program Manager for the New York State Mesonet. We're in Schuylerville, and we're installing our first of 125 New York State Mesonet weather stations. Each installation takes about 7 days to complete. The first day you bring in the equipment, the second day you dig the foundations, and the third day you pour the concrete, and then you wait a couple of days. And we're at the end of those couple of days. Today we're actually building the tower, and it should be completed by the end of today. A few days from now, the meteorologist will come in and finish installing the actual sensors. It'll be a 33 by 33 foot area, and the tower is roughly 30 feet tall, and then we'll extend our sensors up to what's called a 10-meter height, which is the standard for wind sensing measurement. We'll also measure temperature at 9 meters, solar radiation, atmospheric pressure, precipitation, and we also have 3 soil sensors buried at 5, 25, 50 centimeters deep. They'll measure both soil temperature and soil moisture. That's useful information for farmers, for the Weather Service, for hydrological flooding warnings, and a lot of uses for that. This is a lot more complicated because we're in New York. The winter climate's pretty harsh, and so we've had to make a lot of adjustments. The snow height, so everything has to be higher. The solar panels have to be bigger. Heating requirements of the sensors in the wintertime. So it's a lot more complicated. This particular site, it fits our general configuration that we're aiming for across the state. If you scan around, this is a relatively flat field away from the tall trees and the other obstructions. We're fairly near the Hudson River here, so it's a very good site.
Hurricane Sandy, Hurricane Irene, storms upstate, snowfall, flooding. There is a frequency of extreme weather like we have never seen before.
It's forecasted that New York State, the United States, we expect to have more extreme weather in the future.
We're now putting in a weather system with literally hundreds of monitors throughout the state.
The New York State Mesonet is going to be a game changer.
The University of Albany is leading the deployment of the New York State Mesonet. We're partnering with the National Weather Service, the Division of Homeland Security and Emergency Services. We're going to deploy 125 weather stations across New York State.
Every county will have at least one weather station in it, and this is important for serving the populations of the whole state.
From New York, Long Island, Hudson Valley, Adirondacks, Central New York, Western New York.
We currently have gaps in the observing network across the state, serious gaps, and by building the Mesonet, we will be able to fill those gaps, and this is going to allow us to not only see the weather better, but also to better predict the weather.
The ultimate goal for the Mesonet is to provide early warning for New Yorkers. And the way we do that is we provide more high-density weather information to the Weather Service and to the Office of Emergency Management.
Emergency operations and emergency management, to me, is one of the most critical roles that government plays. Because it's very simple. If emergency management works well, you save lives.
The New York State Mesonet is going to be providing data every 5 minutes, and this is absolutely crucial for people having to make decisions in the field, whether there's a flood risk, whether you need to evacuate. You really need this fast, accurate information that the New York State Mesonet will provide. If we had had the New York State Mesonet during some of these recent extreme events, then we would have had better real-time information about what is happening, where it's raining the hardest, how the rivers are rising. Having all of this data available ahead of the event allows us to better forecast the risk of extreme weather.
The technology that we're using is best in class. It's the most advanced technology that's out there.
And that's because we are going to include, for the first time over much of the state, profiling technology. Now, a profiling site is one where, instead of just observing the surface-based data, which Mesonet would traditionally do, we will be remotely sensing the lower parts of the atmosphere.
That's important because that's where a lot of weather takes place, especially with respect to severe weather. We'll be able to see that, whereas now you can't see that with the current technology that you have. Obviously, our immediate objective is to provide better early warning in the event of severe weather. But the benefits of Mesonet will go well beyond that.
We will be providing for the first time across the state soil moisture information, which was crucial for farmers to plan crops, for example.
We'll be able to help give guidance for industry like trucking, energy companies for the aviation industry. So we think that there's considerable economic benefit from having this system in New York State.
When we are done, we will have, I believe, the most sophisticated weather detection system of any state in the country. Not just because it's a convenience, but because it's about safety.
And we're going to be one of the most advanced Mesonets in the country, if not the world.
So that's the New York that we built. And when we made those decisions, it made sense. But again, it's time to now reimagine New York. And the federal government's action and the $60 billion supplemental gave us the means to actually do this kind of extensive redesign and reimagining. We have done a wholesale reimagination of the state and the fundamental services. We start with weather detection because we need an early, accurate, and localized weather information system. I can't tell you how frustrating and how dangerous it is not to have the accurate weather information on a timely basis. We have been in situations where we've deployed equipment to the wrong end of the state because we relied on weather predictions that turned out not to be true. New York State has 27 sites where the weather is detected. That then feeds the National Weather Service. We want to have the best weather detection system in the country, which would have 125 stations, up from the 27 stations, and much more sophisticated weather stations. These weather stations would determine not just the traditional criteria, but also air, soil, radiation. They could tell us when a flood is coming. They would then communicate with our Homeland Security, National Weather Service, and the University at Albany, and also to the public. So we would have information on a real-time basis that is accurate. In terms of early detection of flood risk, road icing, power grid threat, wind events, man-made hazards, it is essential that we have this kind of information, and we believe it will save lives and protect property.